All right, let's do a couple more example problems. So here you have Jim. He's got 6 different books. First question, find the number of orders in which the books can be arranged on a shelf. So we've got 6 different books, and we're trying to find the different ways to look at those. So a couple different ways to think of it. You could just do 6 factorial. Okay. You could think of it in terms of a permutation because order does matter. We want to see, you know, it's not just, if there was just, you just threw all 6 up there, it'd be basically one way to do it. But we're looking at specific orders. So you could think of this as being 6 books taken 6 at a time. Okay. And if we do that on our calculator, again, we get 720. Okay. You can multiply it out longhand. If that makes you more comfortable until you get comfortable with permutations, it's basically the same problem we just already did with the lady putting 6 people at a table, so I'm not going to spend a lot of time on it. Now, here's where it gets a little bit tricky. So now we're still with Jim. He has 6 different books, but the shelf only has room for 3 of the books. So what are the different ways that 3 of the books can be arranged? So now we're taking 6 things, and we're doing a permutation with 3 at a time. Okay, so now if we do this the longhand way, which is good for you to know, remember the formula was n factorial over n minus r factorial. And of course, n is this number, r is this number. So it's really 6 factorial over 6 minus 3 factorial, which is 6 factorial over 3 factorial. Okay. 6 factorial is 6 times 5 times 4 times 3 times 2. 3 factorial is 3 times 2. The 3's and the 2's cancel out. We're left with 6 times 5 times 4, which is 120. That's a quick mental math problem, and for a lot of kids, it's really better to keep working it out until you get it. I just did 4 times 5 is 20, times 6 is 120. However, you could also do this on your calculator. This glare is something terrible. So first thing you would do is put in the 6. 6. Then you're going to hit PRB. You're going to keep the permutation button, hit enter, so we know we want that one, and then the 3. And then hit enter, tells you 120. Same thing we got. Okay? Alrighty. So question 3, from a class of 25 students, how many different ways can 4 students be selected to serve in a mock trial as judge, defending attorney, prosecuting attorney, and the defendant? So first thing you need to ask yourself in any of these types of questions is, does order matter? Does order matter? And right now you're probably thinking, well, sure it does, because right now we're on the permutations lesson, so that seems really easy. It's like, well, she hasn't taught us about combinations yet, so it's going to be a permutation, but life is not always that easy. Does it matter? Yes, we specifically have a judge, a defending attorney, a prosecuting attorney, and the defendant. So that's basically 1, 2, 3, 4 specific roles, just like it said here, and it matters who is who. So it's not just a committee. So basically what we are looking at is 25 students in a permutation taken 4 at a time. This is how we set it up. Okay, and now from here, okay, you can do it longhand, use the formula like we did up here, so that's basically 25 factorial over 25 minus 4 factorial, which is 25 factorial over 21 factorial. And by now you're probably figuring out that in the 25 factorial, anything 21 and down is going to divide out. So if you're doing this longhand, you should have figured out by now that that's really going to be 25 times 24 times 23 times 22, and I'm not even going to bother to write everything else out because I know that anything 21 and below is going to cancel out. So I could do this one longhand this way, or we could use, I'm going to see if I can turn off the light and have less glare. See if that's better. Oh, maybe not. Oh, can't see anything. Nope, that's not better. Okay. All right, so let's clear. 25, PRB, enter, 4, enter. 303,600. And if you're not sure, go back and multiply 25 times 24 times 23 times 22 and see what you get, okay? And you could be using your graphing calculator for this as well. All right, 10 cyclists in a race. How many ways can the 10 cyclists finish in first, second, and third? First question, does order matter? Do we care? Okay, if we care about order, then that means it's a permutation. So it is. We are looking for a specific first, a specific second, and a specific third. If you think about races, you know they usually get different medals or ribbons like blue, red, and I think yellow. Third place, green. I don't remember what third place is. Gold, silver, bronze medal. How about we go with that? So it does matter. So we're looking at 10 total, permutation taken 3 at a time. All right. So the longhand way, that ends up being 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial, which is 10 times 9 times 8. Or you're welcome to do it using factorials in your calculator, 10 factorial divided by 7 factorial, or with using the permutation button. Either way, 720 different ways. And what you're going to notice over time, you get a lot of repeats here. 720 is a pretty common answer. 120 shows up a lot. So depending on, I don't know, just seems like the same numbers keep showing up whenever I do problems. All right, so now some points to ponder here. We want to make sure we understand which situations represent permutations and which represent combinations, okay? And I just want to give you a reminder. Order matters in permutations, okay? Order. And remember, O and P are next to each other in the alphabet. In combinations, order doesn't matter. Or like I like to say, who cares? Again, C, if we say who cares about order, that's a combination. All right, so why don't you real quickly think these through. Toppings on a pizza, letters in a password, members on a committee, first, second, and third place finishers in a race. I'm going to let you decide which one you think is a permutation, which one's a combination. All right, CP, CP. So letters in a password, order matters. First, second, and third place finishers in a race, order matters. Toppings on a pizza, we're just going to throw them all on there. We don't care. And members on a committee, we're just going to throw them all in a room, don't care. Hope that was helpful. Love you lots. See you later. Bye-bye.